So in the previous sections of this course, we have looked into what is decision tree, what are the drawbacks of decision tree, and how we can overcome these drawbacks through the use of bagging and boosting techniques. In this particular session, we will be using a bagging technique which allows us to reduce the variance in a decision tree. And the algorithm that we will be focusing on is called random forest. So why this name? What is so random about this random forest, and what is the specificity of these particular terms? So random forest is an extension of the bagging technologies, but it has an extra step added to it. So the random terms comes from the meaning of selecting the features that we are going to use to build this data set, and also randomly selecting the data sets that we are going to train our data. So essentially, we are not just limiting to the bagging concepts of taking a random subset of the data element, but we are also taking a random subset of the features that we are going to train this model. So essentially, using this, we build multiple trees, and as we know, where there is a lot of tree, we call it a forest, and hence the term random forest. Let's see how a random forest is actually built. So in accordance to what we have talked about, suppose we have a data set of m elements and we have features of n number of sets. The first step is to take a subset of the data set. That is, we take a subset from the m amount of data that we have. And the second step is to take a subset of the n features that we have. After we have this, we build our decision tree. Now this is the first tree that we build. We iterate over this process multiple times and create multiple decision trees, and we aggregate all these trees or ensemble all these trees to build a final model which we call as a random forest. Now this random forest, since it is built on multiple subsets of the data and multiple subsets of the feature, we have a very low amount of variance associated with the final ensemble model. And hence this allows us to reduce the variance that is being present in a single decision tree model. So using this technique, we are able to reduce the variance and effectively build a better model, a better robust model for our business. So to jot down what are the advantages and the disadvantages of using random forest. So the first advantage is we can use high dimensionality data for random forest. So if we have thousands of data elements, if we were to build a single model, it would be very heavy and it will be computationally very exhaustive to build this model. So as this algorithm goes, we take subset of the data, so we are not at a single time using all the thousands of features that is there to build the model. So essentially it reduces the computational power that is required to build this model, and at the same time it reduces the variance. It also is able to handle missing data quite efficiently, and as such is able to perform much better than the other simple decision tree models. However, what is the disadvantages? All seems too rosy for random forest. So what is the main disadvantage of using random forest? So basically, since the final prediction is based on the mean of the predictions, that is the mean of the decision trees that we are building, the mean predictions for the subset tree, it won't be as precise as developing a single model which consolidates all the data element, since there will be some information losses in the multiple trees that we are building. So that is the only drawback of random forest. Apart from that, it takes good care of the amount of variance that it can be reduced from a decision tree. With that, we conclude this session on bagging techniques and a good example of bagging techniques called random forest. And I hope you understood what is so random about the random forest. Thank you.